Okay, PreCalc kids, we're going to finish up the second half of the notes for section 5.3 on exponential functions. So earlier in this chapter, we were talking about graphing a number like 2 to the x. So we were talking about that. A new number that's on your calculator that you might have seen before is the number e. It's very important in math. There's a lot of calculations to go along with it. And so here's the definition of e. E is generated by taking any number 1 plus 1 over n to the n power. Or what you'll see in calculus is we say the limit as n approaches infinity of this quantity comes out to be e. So if we do that limit, we get e to be this number. 2.7182 da 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 da, on and on and on. E is an irrational number, just like the square root of 2 or pi. So we are going to be looking at what does y equals e to the x look like. So let's first start off with graphing it. Our base is e to the 0th power. So if we make our little chart, let's just look at -1, 0, and 1. When e is -1, I get 1 over e. When e to the 0th is 1, and e to the 1st is just e. So if I plug in 1, that's about 2.71. If I plug in 0, I get 1. And if I plug in -1, I get 1 over almost 1/3. So e to the x is similar to 2 to the x, where it shares 0, 1 for the y-intercept. And it's also got its domain is all reals. Its range is y is greater than 0. So let's look at a couple other of these graphs, just as an expansion of what we talked about earlier today. So if I have this e to the x minus 3, that's shifting my graph 3 to the right. So if I plug in x, y. So if I plug in 3, I get 1 out, because 3 minus 3 is 0. So then I have e to the 0th is 1, and that makes it negative, so that's -1. That -1 out front flips it. So instead, I'm going to be here, so that's -1. So there's my graph. There's my first point. If I plug in 2, that's 2 minus 3, so that's -e to the -1st power. So that's 1 over -e. So that is a fraction. So that at 2, it's getting smaller. If I plug in 4, I get -e out. So that's 1, 2, 3. So that's between -2 and -3. So look what I have here. I have my graph flipped. This x minus 3 here, let's zoom in just a little bit. That's my shift right. And this negative in front gives me my flip over x-axis. So let's continue looking on at some of these other graphs. If I have y equals x plus 2, if I look at this x plus 2 here, that's a shift left 2. So how do I shift my graph left 2? So at -2, I'm going to get 1. At -3, I'm going to get 1 over e. And at -1, I'm going to get e. So let's label these. This is negative 1e. This is negative 2, 1. And this third point is negative 3, 1 over e. Once I get my points, we're growing exponentially. So again, the domain, all reals. The range, y is greater than 0. If I look at my last graph, e to the x plus 2, I have that number on the outside. This is a shift up 2. So instead of my y-intercept being at 1, it's going to be at 3. If I plug in 0, I get 3. I'm going to have my horizontal asymptote at 2. At 1, I get 1 over e. At negative 1, I get 1 over e. At 1, I get e plus 2. So that's almost 5. So right here at 1, it's e plus 2. So there's my graph. If we know how to shift things up, down, left, and right, and flip them, we can graph any one of these shapes. So last bit, this is the fun part. Solving exponential equations. This is all you have to do. If you have like bases, then you set the exponents equal each other. So let's look at a couple of these problems. Here I have bases 3 to the x plus 1. Here I have 81. But I know that I can make 81 to be a power of 3. 81 is 9 squared, which is 3 squared squared. So that's 3 to the 4th. So I have 3 to the x plus 1 equals 3 to the 4th. I have the same base, so I can set these two equal to each other. So really this problem is saying x plus 1 equals 4. I think you guys can solve that. Subtract 1. So x equals 3. There's your solution. Next up, we have this whole jumble. So let's see if we can get the same base here. E to the negative x squared equals, well, if I have an exponent on the outside, I multiply. So that's e to the 2x. And if I have 1 over e to the third, that's the same as e to the negative 3. When I have like bases, I add the exponents. So I have e to the negative x squared equals e to the 2x minus 3. Now I have the same base equal to each other, so I set the exponents equal. Negative x squared equals 2x minus 3. Add x squared, 0 equals x squared plus 2x minus 3. How do you solve a quadratic? Factor it, set them equal to each other, equal to 0, sorry. Numbers that multiply to negative 3 that add to positive 2, x plus 3, x minus 1. So x equals negative 3, x equals 1. Not so bad once you can apply all your products, your properties of exponents. So let's look at the last two. Here, like bases, so I can set these two equal to each other. I have 3x equals 2 minus x. Add x, 4x equals 2. X equals 1/2. Looks scarier than it actually is. Last up, 4 to the x times 2 to the x squared equals 16 squared. So it looks like the lowest base is 2, so I'm going to have to change 4 and 16 into powers of 2. 4 is 2 squared, so that's 2 to the 2x times 2x squared equals 16 is 2 to the 4th, so that's 2 to the 4th times 2, so that's 2 to the 8th power. Last up, I want this to be x squared plus 2x equals 2 to the 8th. Now I have like base on either side, set them equal to each other. set the exponents equal to each other. So I have x squared plus 2x equals 8. Subtract 8, I get x squared plus 2x minus 8 equals 0. So now we're just factoring. Numbers that multiply to negative 8 that add to positive 2. That's x plus 4, x minus 2 equals 0. So that means x equals negative 4 and x equals 2. This is the last bit talking about exponentials. So we talked about how you can, let's just look. What we covered in this chapter, how to evaluate. Laws of exponents. How do you tell if it's something, how it's an exponential function from a table? How do you graph exponential functions? How do you graph exponential functions that are 1/2? Then what we did today. Hopefully this helps. Good luck.